So the image that you see here behind me, it's the most viewed pipe in the safety and quality industry over the past 60 years. Now, I was first exposed to this mangled pipe image as a young submarine officer, learning about submarine design and quality and safety, and the dangers of operating in the deepest parts of the ocean and how unforgiving that it can be. Let me share with you the backstory behind the pipe. It's the morning of April 10th, 1963, and the U.S. Navy's most advanced, deepest diving nuclear submarine, the USS Thresher, has 129 crew members on board, and it's completing its sea trials. Now, it's about 190 miles off the coast of Cape Cod, Massachusetts, in water that is 8,400 feet deep. The surface ship Skylark is in constant communications with the Thresher as it travels to its test depth of 1,300 feet. Now, every 100 feet, the Thresher is pausing just to check the integrity of all of the systems. At 9:09, Thresher is estimated to be at 1,300 feet, and a brazed pipe joint ruptures in the engine room. Water floods in at 100,000 gallons per minute. Now, to get the submarine to the surface, the captain orders all ahead full speed, and he attempts to blow the air into the main ballast tanks. The high-pressure air is not filling the ballast tanks. At 9:11, water is flooding into the compartment. It shorts the electrical panels that are running the main coolant pumps, and those lose power, and it shuts down the nuclear reactor, and all propulsion is lost. At 9:13, Skylark receives garbled communications. Experiencing minor difficulties, have positive up angle, attempting to blow. They again attempt to blow air into the main ballast tanks, but to no avail. At 9:16, they receive garbled communications that they're 900 feet below their test depth. They're at 2,200 feet. And just 2 minutes later, Skylark detects a high-energy, low-frequency noise, characteristics of a submarine imploding. Now, it turns out that the submarine imploded with such force that all that's left at the bottom of the ocean is a huge scrap metal yard. Now, the implosion took 1/20th of a second to happen, which is way too fast for the human nervous system to perceive. Now, in the review of the incident, there were so many things that were exposed. But the primary driver during that time was the Cold War. You know, at that time, the U.S. felt the pressure to get this newest, most advanced technology into the water because Russia had 500 submarines, and the U.S., we only had 150. And, you know, this tremendous leap in technology with this new fleet of U.S. submarines would level the playing field with the Russians. Now, at a really high level, the U.S. Navy allowed too many compromises, too many variations in developing this new weapon system that required a lot more stricter attention and control and better testing. Now, I think Admiral Rickover, he's the father of the nuclear navy, he summed it up best. He said, "I think it's important that we reevaluate our present practices, where in the desire to make advancements, we may have forsaken the fundamentals of good design, engineering, and construction." Now, in my review of it, I think the U.S. Navy went too far, too fast. But 129 people did not die in vain because out of that was born the SubSafe program. It was developed to be a robust aggregation of design standards, procurement, construction, testing, inspection, audits, and operations so that should flooding occur in a submarine could return to the surface. Now, how good is the SubSafe program? It's been pretty good. While the U.S. lost 16 U.S. submarines to non-combat operation between 1915 and 1963, since SubSafe has been implemented, no nuclear submarine has been lost, and nuclear submarines have traveled 51 million miles in the ocean. So it was a really, really powerful framework. Now, this was the framework that I was exposed to, that I lived in for months on end, for years on end. I was not only exposed to it, but I was also tapped to be the submarine SubSafe coordinator to make sure that we were carrying out SubSafe on our submarine. So today, I'm excited to share with you the 5 pillars of purpose-driven safety that I was exposed to in the submarine force, and also then I used in countless companies to significantly reduce safety and quality-related incidents. What you'll see is it's certainly a powerful framework of processes and procedures and testing and inspection, but it's mostly how do you establish a safety mindset, a culture safety. That's what we need so we can be successful.